Now let's talk about the 5-number summary in Boxplots. So this 5-number summary is really just a step along the way to find a box plot. It's somewhat useful in and of itself in that it's telling us where values lie relative to the rest of the data in a data set, because it's giving us our 3 quartiles and then the minimum and maximum value in our data set. Right? That way, if I get any specific number in our data set, I can at least tell where it is relative to the other values. And as I said, this is really just a step along the way to making what's called a box and whiskers plot, or for short, just Boxplot. And that's this thing that you may have seen before. It's essentially a box with a line in it, and then 2 whiskers that extend out on the bottom end and the top end of that box. Sometimes this is arranged horizontally like this, and sometimes up and down like vertically. But in either case, we would need both this box with the whiskers extending out, and we would need a number line to give it some context, right? So as I look at this box here, that's always going to have my first, second, and third quartiles. So the beginning of the box is essentially our first quartile, at the end of the box is our third, and then this thing that splits the box into 2 pieces is the median, or the second quartile. Remember, those are exactly the same thing. So as I look here, I can see the minimum value's about 10, right, because I've got this number line below it. Our first quartile is 20. Our median, or second quartile, is about 34. The third quartile is 60. And the maximum value in this data set is 90. Okay, so these are very easy to read. And if I was told that, right, we've got some value of 45, I know that it's more than 50% of the data, right, because 45 is more than the second quartile. It's somewhere between the 50th and 75th percentile. In other words, no more than 25% of the data could be more than that, right, because it's less than the third quartile. So I've got some ability to kind of place it, any new values, in the context of the other data. All right. So now we've seen how I can use a box plot to get these 5 numbers. What if we started the other way and we had the 5 numbers and we wanted to get a rough sketch of what the box plot looks like? Okay. So we've got a minimum of 19, a maximum of 100. I want to start there because I need to make a number line. Right? So I'll make a number line right here, and I'm just going to start with nice, easy numbers, right? If I go from 0 to 100, that's going to have every possibility in my data set. And then if I just kind of split that up, here's 50, 10, 20, 30, 40. And then 60, 70, 80, 90. I don't expect you to pull out a ruler to do this. What I expect, if I were to ask this kind of question on an exam, is just that you make a reasonable number line and then you put the values where they should be. Okay, so if we go back here, the minimum value was 19. I'm going to show you how to draw this the simplest, easiest way possible. I'm going to just draw a little vertical line above the number line for each one of those numbers in my 5-number summary. I happen to remember this one was 19 and the highest one was 100. Okay, so I've got those marked. And then if I look at the other 3, so I've got 60, 78, and 90. So I'll mark 60, 78's about right here, and 90. Okay, so after I've done this, we're basically done. Here's how I do it. I want to connect the middle 3 into a box, right? So I'm just going to do this and this to turn that into a box. And then I extend these out. Done. Okay. So this isn't an especially hard thing to do. We just need to know how to do it. And we should also be putting on, so this is exam scores, right? This is supposed to be a real situation here. So the last thing I'd want to put is what this is that I just graphed. And I would usually put units, but there's no units to have here. But if it were, weights or something, I'd want to put pounds or kilograms or whatever it is. So just make sure we've got a number line that we start with, a label for that number line so I know what it is we just graphed, and then, of course, this box plot itself. It's a fairly straightforward thing to do. What I don't want to see any of you doing is starting with just like a sketch of what a box plot looks like, and then just write 19, right, this was what, 60, right? Like, this is not reasonable. Do you see how this extends out further to the left than this whisker does? And actually this side of the box is also bigger than this side of the box. That actually tells me it's left skewed. I'm not going to make that part of our course because it's not in our textbook and not part of our homework or anything. But this tells me something. The shape of this box plot is telling me something. And just randomly just drawing a generic shape, right, is sort of like making a pie chart and just being like, here's 1%, 50%, 49%. Like, no, that's not how it's supposed to look, right? So this needs to be scaled appropriately. Draw it this way that I've shown you here, and you'll have no problems with this. So having said all of that, a box plot with only one group on it is far from ideal. To be honest, if I was only looking at one group, like one set of data here, not broken into any groups, I should have made a histogram, because we actually know how to call that symmetric, left skewed, right skewed, bimodal. We can detect outliers with it. I can't detect outliers with this, right? So I get so much more with a histogram. This is not to be used really for just one box in it, in this box plot. Here's where we would do something like that, is when we've broken our data into groups. So this is a box plot of the number of hours worked last week, broken down by the gender of the individual. And before we start making any, this is real data here, but before we start making any claims about this, I just want to say directly, this is self-reported data. So this says more about what people say they do than what is actually occurring in the workforce, because this massive difference that we're seeing between these two essentially disappears when we look at HR data. So this is really just telling us that men are far more likely to say that they work a ton, and women are less likely to say that they work a ton. But anyway, I just wanted to get that out of the way before we start making conclusions about, oh, men work so much harder. That's not what we're seeing here. This is men say that they work more. Okay? But having said that, right, let's look at this, right? So we see that 40 hours a week, right, kind of our standard for full-time, whatever, salaried employees, is the first quartile for men, but it's the median for women. So in other words, half of women say that they work 40 hours or less, and only 25% of men say they work 40 hours or less. 75% of them are saying they work 40 hours or more a week, whereas only half of women are saying that. All right, so I'm able to make those comparisons between these groups. And I can even say that, okay, like 25%, right? So this end of the box for men here is about, what, let's say 53 hours a week. That means that 3/4 are less and 1/4 is more. So in other words, 1/4 of men are saying they work more than 53 hours a week, which is simply not backed up by real data, right? This is what they're saying. Whereas for women, right, I don't know, what is that, like 42 or something is the third quartile? And that's to be honest, far more realistic number, that 1/4 of women are working more than 42 hours a week. All right, so anyway, that's what's going on with these, and what we're really trying to do here is compare across different groups. That's the purpose for this. If I had 2 histograms, it's very hard to do those comparisons across different groups, especially when it's like 5 different groups. So that's what this is really for, is for comparisons across different groups.